Hello everyone, how are you all doing today? In this video, let's try to integrate this complicated looking function and let's try to do it in the most simplest way as possible. If you notice here, the numerator is a composite function. Remember that in integrals, whenever you see a composite function, chances are it is U-substitution. What do I mean by composite function? Is when you have function within a function. So let's say if you have a function f of g of x. This is called a composite function because it's a function within a function. Here g of x is called an inner function and f is called an outer function. In this example, we have square root of tan x. Here tan x is the inner function which is like g of x, and that f is a square root function which is the outer function. Whenever you notice a composite function like this in integral, chances are you have to put g of x is equal to u. Remember that you can only do that substitution if the differentiation of g of x, g dash of x, is present in the integral. In this case, g of x is like tan x over here. So if I have to put tan x is equal to u, the differentiation of tan x, which is sec square x. So remember, let me write that down. The differentiation of tan x is sec square x. It should be present in this integral. I don't see sec square x in the numerator here, but I do see there is a cos x in the denominator. That means 1 over cos x, at least there is one sec x present here. If you want to bring one more sec x here, you will need one more cos over here. If you need one more cos, you'll have to multiply and divide by one cos in the denominator. Now let's see how do we do all of that. So we have integral of square root of tan x divide by, I already have sin x. Notice that I need one more cos x. So let me multiply by cos x in the denominator. So let me write cos square x, and then let me also divide by cos x. So essentially what I'm doing is I'm multiplying and dividing by cos x. If I multiply by cos x, this cos x became cos square x, and essentially I'm also dividing by cos x to nullify that effect. Okay, if you notice, this is essentially the same thing. This will get cancelled, and this is essentially the same thing. What is there over here? So now what you can do, the advantage of doing this is this part over here, you see, is tan x now. Okay, and this 1 divided by cosine square x is nothing but sec square x, which is the differentiation of tan x. So what you have here is integral of square root of tan x, okay, divide by tan x, and here 1 over cosine square x is nothing but sec square x, and you are integrating that with respect to x. Now it's very easy to integrate because we can simply now put tan x is equal to u. Okay, since we put tan x is equal to u, we'll have to convert the entire integral now from the x world to the u world. So we'll also have to convert the dx in terms of du. So we'll have to differentiate both the sides with respect to x. We know that differentiation of tan x is sec square x, and then dx is equal to du. So if you notice here, this sec square x dx, that is nothing but that du. Okay, so now let's convert that entire integral from the x world to the u world. So now you have integral of this is nothing but square root of u divided by u. Okay, and then this part sec square x dx is nothing but du. Okay, now we can simplify this using the law of indices or law of exponents. This square root of u is nothing but u to the power half, and divide by u to the power 1 with respect to u. And since the base is same and it's getting divided, we can subtract those powers. So we have half minus 1 with respect to u. Okay, and we know half minus 1 is nothing but minus half with respect to u. Now we can just apply the basic algebraic formula of integral. So the integral of this is nothing but u to the power minus half plus 1 divided by minus half plus 1 plus constant of integration c. Remember that u was nothing but tan x. So we'll have to convert it back to the x world. So we have tan x minus half plus 1 is nothing but plus half. So I have tan x to the power half divided by half plus constant of integration c. And this half or this 2 is in denominator's denominator, can be taken in the numerator. So this is nothing but 2, and tan x to the power half is nothing but square root of tan x plus constant of integration c, and this is nothing but the final result of this integral which we solved using u substitution. The tricky part here was when you put tan x is equal to u, you'll have to make sure that the sec square x, which is differentiation of tan x, is present over here. If you are looking to master calculus and integrals in general, hit that subscribe button today. I do post math and calculus content every single day. I'll see you tomorrow.